So, we've explained matter. We've explained the universe out there. Well, not quite. We've explained between about 1 and 10% of it. There's a little bit, the majority of it, is some mysterious stuff called dark matter. Now, this is very odd. There's stars or stuff out there that we cannot see, yet we know that it's there. Now, how on earth do we know that? Let me show you a picture. This is a picture of a spiral galaxy. It's just like a Catherine wheel going around on firework nights. You can get the feeling of the thing whirling around like this. It's not just the feeling of it whirling around, it actually is. How do we know that? Well, we go and look at the light being emitted from the stars. Remember when we were whirling around and you heard the pitch going up and down as it came towards you and went away from you? Same thing with this. You look at the light from the stars on the edge of this spiral galaxy and you find some have been shifted towards the blue, as if they're coming towards you, and some have gone to the red as they go away. So from this you get the feeling that this whole galaxy is swirling around, and you can measure the speed that it's swirling around. We can also weigh it. And what we find is that when you weigh the galaxy and compare it with the speed it's whirling around, the sums don't add up. Let me show you what I mean. I asked Bryson to make a galaxy for us, and he's obliged. And this is what happens with a spiral galaxy. The thing is rotating around, and there's some stars sitting there quite happily. But what's supposed to happen, according to our sums, is the following thing. If our sums are right, the stars should just fly off because it's going around so fast. Yet they don't. Let's just look at this picture again. So, we see these stars whirling around and staying in the galaxy. Yet, when we look at all the matter in the middle, the amount of gravitational tug that it can provide to hold them on the trail isn't enough. Those stars have no right to stay there. They should just fly off the wheel, like in Bryson's demonstration. How do they stay in place? There must be a much bigger tug going on to hold them there, provided by stars that we can't see, dark matter. Now, it's not just this one galaxy that's got this problem. There are many, many like this, and not just individual galaxies. We see galaxies and galaxies rotating around each other, and we begin to find that the sums don't quite balance. It really does look as if there's this dark matter in the universe, maybe 90% of it. Now, how on earth do we go and look for dark matter? Well, one way is by analogy with H.G. Wells' story about the Invisible Man. You didn't see him directly, but when he bumped into things, you were aware of his presence indirectly. That's the sort of thing we're doing here. Now, what is really exciting is that as I was preparing these lectures, the first news came out that perhaps the first sightings of dark matter had been made. And this is shown in these pictures that were published just a month or two ago. Some astronomers were looking at some stars, and it's been processed through the computer. You see these little pixels to show the stars. I want you to focus on this star in the middle, and we're going to play in a moment. We'll show what happened over a period of weeks. So this was at the beginning of a period of time. Now, a few weeks later, this had happened. Suddenly, it was brighter in the middle, and then a bit later still, it had dimmed away again. So there you are on Earth, looking out at a star in the distant heavens, and suddenly it gets brighter and goes away. Now, what's going on? The idea is that a dark star has come between you and it. Sounds very odd. Let's just look at this again fast to convince ourselves that it is brightening and going away again. So, that's what was seen. How on earth can it be that a dark star has come between your eyes and that distant star and made it brighter? You would think that it would block it out. No. Another of Bryson's amazing replications of the universe here will show us how this really works. Now, this might look to you like just a sheet of latex rubber, but in actual fact, this is the universe. And at this end, we have got the astronomer who is going to be looking out at a distant star. And at this end, we have the star. Now, can I have a volunteer to send me some light beams from the star? Would you like to have a go? Right, what's your name?
Paul.
Hello, Paul. Now, could you just roll a couple of balls from here? First of all, just roll one straight so we can get the idea across the flat plane. So you see, this would just come straight in to the telescope waiting to receive it. Now let's see what happens when I put a dark star in the middle. OK, fire one straight at it again, see what happens. It hits, you see. You don't see that one. But let's see what happens to a light beam that goes slightly to the side. You want to move that slightly to the side, that's right. Now let's see what happens with this. You pick it up, you detect it. It's got bent. Let's try with a light beam on the other side. OK? Fire us a light beam. That also got bent. So suddenly you're seeing more than you would have done before. Thanks very much.